This is the TurtleBot3 Autonomous Navigation demo. The first demo we'll be walking through is the Simultaneous Localization and Mapping, or SLAM, function of the TurtleBot. SLAM is what allows the TurtleBot to detect its environment using its laser distance sensor, and to record that environment into a map for later use. There's a lot going on this screen here, which is why I have it paused. I'm going to walk us through it before I continue the video. What we're watching now is a screen recording that I took while I was controlling the robot. There are 3 windows open. In the top left is the bash terminal. I used this to source the software environment that the TurtleBot is running, and I'm currently using it to control the TurtleBot velocity using my keyboard. In the bottom left is a map. This is the map that's being generated by the SLAM algorithm. And to the right is a video feed, which is coming from the webcam that is mounted on the TurtleBot. Throughout this demo, you will see 2 additional video feeds pop in and out of the frame. This one on the bottom right, and then this one in the top left. They come into view when we can see the TurtleBot navigating through these spaces. It helps to give us more insight into how it's moving. Take note that these 2 video feeds are overlaid on top of the screen recording that we're watching. They are not coming from the same computer. And with that, let's map this laboratory. This next demo shows how the TurtleBot can move autonomously to a goal position within the map that it's just created. To begin, we give the TurtleBot an estimate of its position in its environment. Now I'll reorganize the windows a bit so that we can see things on the screen easier. And before we move any further, I'll talk through how to interpret this window in the bottom left of the screen. This is how the navigation software visualizes the TurtleBot and its environment. The black and white lines that are surrounded by pink are the global map. This is the map that was loaded into the navigation software when we began it. The TurtleBot itself is represented by the mass of coordinate frames you see here. These coordinate frames correspond to the sensors and actuators that are mounted on the TurtleBot, like the laser distance sensor and the wheel motors. The diamond of blues and reds that surrounds the TurtleBot is the local cost map. This is a representation of the TurtleBot's immediate surroundings, which is fed by measurements from the laser distance sensor. And now that I've explained all that, I'll go ahead and give the TurtleBot its first navigation waypoint. Doing so has generated a new thin line between the TurtleBot and its goal position. This line represents the output of the path planner, which directs the TurtleBot to its goal, taking into account the global map. It is then a local controller, which moves the TurtleBot along this path towards the goal. This local controller must also consider real-time sensor data, the local cost map, and other objectives such as smoothness of motion and obstacle avoidance, which is why you may notice the TurtleBot does not always strictly adhere to the path plan. The webcam mounted to the TurtleBot streams both video and audio. I have the audio turned off for most of this demo so that we aren't listening to the motors spinning in the background. But I'm about to turn that audio up to give an example of what it would be like to have a robot monitor with both video and audio something of interest. A pump jack, for instance. This next demonstration will have the TurtleBot move through multiple waypoints, which demonstrates that it can both follow more complete paths and exemplify how it might be used to patrol an area. This next demo is similar to the last in that the TurtleBot will follow a set of waypoints, but this time the TurtleBot is going to encounter an obstacle it wasn't expecting. This obstacle is one that was not there when the map the TurtleBot is on was originally created. You can see how the path is currently planning for the TurtleBot to move around the farthest obstacle. But then the TurtleBot notices that there's actually an obstacle blocking that path. So the path adjusts and the controller moves the robot through the free space. This demo challenges the TurtleBot to navigate itself out of a tight spot. You can see in the bottom right video feed that the TurtleBot is surrounded by 3 bottles. Its navigation goal is behind these 3 bottles, so it has to maneuver itself out and over to the navigation point. This last demo shows how the TurtleBot responds in a dynamically changing environment. To simulate this, I walk next to the robot as it moves, and then actually in between it and its goal before I move out of the way again so that it can continue. The TurtleBot in response stops, backs up a little bit, allows me to get out of the way, and then continues to reach its navigation goal.